passengers, welcome to your flight with zeroG. Today's destination, the truth. Please stay curious and enjoy the ride.
Hello and welcome to Data Waypoint, zeroG's very own podcast where we talk about the use of data and machine learning in commercial aviation. This episode will be all about building artificial intelligence solutions for revenue management. And with me today, I have Tobias from Eurowings taking care of offer management at this point-to-point carrier, as well as Christian Ritter, who is zeroG's very own lead data scientist, who worked together with Tobias on building artificial intelligence for predicting customer demand over time. Welcome, Tobias. Welcome, Christian. Happy that you guys are here. I'm very excited about talking about this topic. I think it's an exciting topic. Not a lot has happened in commercial aviation around applying and building bespoke or tailored machine learning applications that can support revenue managers in their day-to-day decision making, and also looking at ways to automate certain processes that are currently mainly manual or inspired by gut understanding or very clear understanding of the market. So I'm curious how data and machine learning can support revenue management overall. And we've been working together for the last, I think, 2 years since the COVID pandemic hit, creating very unique challenges for the commercial aviation industry as a whole, and also opening the opportunity to find new ways, more disruptive ways as well, to think about how we can do offer management and revenue management for commercial airlines. So Tobias, welcome. It's an honor to have you here. Can you tell me a little bit about what you do at Eurowings, what your team does at Eurowings, and the overall business model at Eurowings?
Yeah, thanks for having me here. First, maybe concerning Eurowings, we're a point-to-point carrier in the European market, a little bit decentralized with different home bases in Germany, and multi-channel strategy. So we serve tour operators, we serve groups, we serve point-to-point, single-seat business. And me and my team, we're taking care of the system landscape for revenue management, consists of tour operator applications, of group applications, and also of the heart of revenue management, the forecasting and the optimization.
Excellent. As I said, it's great to have you here and talking about machine learning in customer predictions. Christian, can you talk a little bit about the role of machine learning, what machine learning actually is, and have a demystify the topic of machine learning?
Certainly. So it's a very broad topic, so I'll probably oversimplify it a little bit here. But in general, what we try to do with machine learning is we try to approximate a function or a model as good as possible, where we only have measurements of how the world works. So for example, for revenue management, we want to predict the customer demand, but we don't know how the actual demand works. We can only make assumptions. So with machine learning, now we try to build a model that tries to predict demand as closely as possible with the limited information that we get in the real world, because everything is noisy, everything is statistical, and that's where machine learning can really help. There are a lot of other applications for machine learning as well, from computer vision to reinforcement learning to unsupervised learning. But for this specifically, it's more about predicting customer demand, which is something that we can do with these modern technologies that try to derive patterns from your data and use those to make predictions.
Excellent, thank you. Before we started on this journey together with Eurowings, Tobias, there was a certain way that you guys were predicting customer demand. And at some point in time, you started to understand that machine learning itself can be of an additional benefit for your team and for Eurowings. So can you describe us a little bit how you used to predict customer demand and why at some point in time you were like, well, there's got to be a different way in which we're going to use modern machine learning to improve this process?
Yeah, sure. So we started our journey during COVID. We saw a change in demand patterns, also the change of demand quite frequently we have never seen before. So we have to deal with an optimization setup. We have to solve what's the right price with the right availability at the right time. And this new challenge during COVID led us to an idea, what should we do, where are new ways to go. We offer our analysts a tool set they can use. This is a graphical user interface, this is reporting, this is also forecasting and optimization. And we were thinking, how can we adapt to these changes in demand we see in the market during COVID, and what new technology is available to make predictions more accurate than in the past. And that's where the journey started together. We approached you, seeing if there is new methodology available to predict, to react quicker to changes in demand. And this is where the product we're going to talk about came from.
Perfect. Yeah, that's I think the one of the topics that usually is a little bit of a challenge, and I've alluded on that as well, is that machine learning sometimes can be a little bit of a big topic for people. Yeah. So how did you approach that within the team on a change management level? Like, how did you approach? Was there like a big acceptance within the Eurowings team saying, "Hey, we need to change something," or is it more like, well, the way that we're currently working is already kind of like working. We need to tweak just a little bit. So how do we approach, or how did you approach, so to say, this topic within the team, and how did you do and facilitate that change management process?
Yeah. The decision of price and inventory consists of many steps. So first of all, I think it's really important to mention we didn't change the entire processes of how our analysts do revenue management. We just target one specific part of this value chain. And we started with an MVP. Certainly this was a new topic also for us. So what did we do? We said, let's set up a proof of concept, very pragmatic, on-hands mentality, to see on a very diverse route set we have at Eurowings if a new approach of forecasting leads to better results or good accuracy. And this is what we did. So first important point, we didn't change entire revenue management process. We just focus at one point. And the second is we did an MVP to prove that new methodology can lead to very good results. And I think this was crucial for people to see the results, to understand what's happening, even if they lost some control. It's a little bit like a black box also that was new for us. But seeing the results lead them to a certain kind of acceptance and certainly help in this change process.
Yeah, I think that's like, because revenue management really is the heart of an airline, making sure that an airline is operating profitably as well as commercially sustainable. To not implement any new big technologies at scale directly, but really test and try out hypotheses first on the selection and then incrementally include other parts of the network until there is a solution that can actually work. That's, I think, a very important element whenever we introduce new data or machine learning technologies, that it is incremental and a soft landing, so to say, and a soft opening or usage of these kinds of technologies. Christian, the moment, and we love this, so as soon as an airline walks to us and says, we have lots of data and we want to change something using machine learning or modern data science technologies, that's where we get excited. I know you get excited. So from a data perspective, how did we approach this topic? How did you approach this topic? And how did you kind of like tackle it both from a technical perspective as well as from a model perspective? So data technology as well as a modeling perspective. Try and optimize for the goals that Tobias and his team had.
In general, I think for every data or data science project, it's always important to start with the sources that we have, the building blocks that we are working with, which is the data. So the first step is always to analyze the data, see what is there, what is not there, what kind of correlations do we see in the data. I think what's also important to highlight is that we always try to talk to the experts as well. Because there are, especially at Eurowings, they have a lot of revenue management experts who already know the data, who work with the data for years, who know their business. So we also try to understand the business and how they operate, because that is a crucial part of the final solution. And it needs to be taken into account in order to implement a successful application. So I think that's how we started. So we looked at the data, we talked to the experts to really understand what was going on. And then you usually have like an experimentation phase where you think about how you can build a model that predicts the outcome that you want. In our case, this was mainly the passenger demand. So we looked, what do we have in the data? What kind of features can we use to make a prediction and to train a model? And then we set up pipelines in order to build those features, to train a model, and then to also evaluate how the model performs. And then we can compare different model variations and iterations in order to find the best model. Also, what's very important here, I think we had a close cooperation with the users as well. We had a very close exchange. We tried to get feedback as soon as possible when there was some predictions to also see, okay, are we going in the right direction? Is there anything that the users feel is missing that we should improve? And also, does it provide the output in a way that the users can understand it? So as Toby mentioned, it's a black box, but I think we always also try to educate the users, at least on a basic level, of what we are doing, so that it increases the acceptance, but also helps them to help us make it better.
So looking at, like, from a data science perspective, we focused on customer demand, right? Every airline needs to do customer demand.
How was it done before? Okay. Why are we doing it?
Yeah.
Yeah, I think it's an important question to understand why do we do this? Why do we do it differently? And I think you already mentioned that COVID was very tricky there and was one of the main reasons why we did this project, which we call Infinity. And it's that historically, or a lot of revenue management systems look at like a year-over-year kind of forecast. So if you want to get a demand forecast for a certain flight, you look at a similar flight in the past, usually the same flight, plus maybe flights that happened a little earlier, a little later, and that is used as a prediction. Historically, that has worked pretty well because there was not too much change in demand between markets, especially if it's a very established market where you have the same kind of capacity over the years, then the predictions work really well. Now with COVID, that completely changed because the markets went completely crazy. They were super dynamic, very volatile. There were airports were closed, destinations opened up super quickly, then closed again. So it was very hard to adjust to that. And that's where the old approach kind of fell flat. And what we now try to do with machine learning is utilize this like pattern-based forecast in order to be more dynamic and to react much more quickly to changes in the booking behavior and to other factors that we can take into account. What do I mean with like pattern-based forecasting? Instead of just looking at a similar flight or a set of similar flights from the past and using those for forecasts, a machine learning model is trying to extract certain characteristics from flights that lead to or that add to a certain outcome. And now if we have a new situation, the model can still extract those patterns, and based on the characteristics of a new flight and the booking behavior of that new flight, it can make a reasonable prediction. And for that, that's the other benefit, is like we're not only taking the similar flight into account, but also the whole network. So we look at the whole network of Eurowings and use that to make a better prediction. So if there are similar markets with similar characteristics, this is also taken into account. And it helps us to much better adjust to dynamic behavior and also to, for example, new markets or markets where we don't have that much data available.
Maybe to add that adding new data is easier or more feasible than maybe in the current setup we had before. So we often think about what additional data source can contribute to forecast accuracy. Certainly there are data sources that are promising but that not really contribute, but there are data sources that really help, like the competitor prices we included. So using this machine learning model also helps us not only to model, to use existing data already in a more adequate way, but also adding additional data sets easier than we could do this in the past.
And before we started this project, like what was your gut feeling, Tobias, about like this approach? Yeah, so going from a more like linear regression model to predict customer demand towards a machine learning based model using data from the entire network as well as additional data sources. So what were your expectations? I mean, I guess like hopes were high, but how did you kind of like approach this topic from that perspective? So like, what were your expectations? What do you think were possible, was not possible throughout the project?
Yeah. I mean, if we talk about forecasting optimization, this is the core of revenue management. So if I think of the revenue an airline obviously generates, it's mostly through fares, so the impact is huge. So even low percentage of forecast accuracy increase could lead to huge revenue impact. So the hopes were high. This was a new approach for us. We knew it would also be a little bit of paradigm change for us in revenue management, understanding exactly what happens with the data, seeing the results, we see the results, but we cannot really comprehend what's happening in the back. And when we did the MVP and we saw the good results, obviously very happy. And this was then the approach to say, hey, let's scale it. So yeah, if we talk about projects in revenue management, certainly we talk about projects to increase revenues here a little bit, there a little bit, but touching fare optimization with new technology we did not use before could lead to great revenue impact, and that's what we saw.
And you basically focused on the proof point, yeah? So just fact-based, if it performs better than what we used before.
Yeah, that was very important, and that was clear from the beginning. Let's do an MVP in difficult COVID times. Let's see if this works for our business model. We have multi-channel mix, we have two operators, we have high seasonality. So this was challenging, and I personally heard a lot about new machine learning approach, algorithms that help airlines to predict demand. To be honest, I want to see it with my own eyes, so that's why we did the MVP with a certain number of routes and really prove, hey, we really see good results, and release workload also from the analysts. What's an important point, I assume, because they can to some extent rely on the data, not needing to configure historical data by themselves. So big impact for us. Yeah.
Excellent. So Christian, throughout this project, we're building really, I think, like one of the industry first applications in using machine learning to predict in a novel way how customer demand develops over time. What kind of challenges did you face throughout the project? So like what kind of challenges did you face building this kind of like machine learning application? As I said, because it's such a novel approach.
I think the challenges were kind of twofold. So on the one hand, we had like the more technological, methodological challenges, and on the other hand, the change management, the how to integrate the user, how to integrate it into the workflow of the users. I can start with the first one, which is like from a methodology point of view, there is a lot already done in terms of research for revenue management. And it's a very complicated topic. So revenue management is not trivial, of course, otherwise everyone would have solved it by now. Yeah. And that also poses quite some challenges when you want to build a machine learning model in the area of revenue management. So for example, when we want to predict a demand, we always want to predict a so-called unconstrained demand, which is how many people would be willing to travel if there was no limitations on capacity and if the prices were basically free, which is something that we never measure because obviously there's no way of knowing how many people would want to travel if it was free because you only see the people that actually travel. But in order to obtain this kind of unconstrained demand, it's a very challenging process that we had to figure out, okay, what methodology do we use from research in order to get this value? How do we feed that into our model? And then also how do we feed the right features and characteristics for the bookings or for the individual flights into our model in order to become more dynamic and adjustable to the change in situation, which require to add additional data sources, as Toby mentioned, for example, competitor data, but also data about seasonality, data about other flights in the network, and so on. And then it's just a lot of iterations. So you try something, you get feedback, you calculate, you evaluate your model against the other models, and you iterate for so long until you reach a point where you are happy with the model and satisfied with the results. The second challenge that I was mentioning is more of the how to integrate the user. And I think that's also very important to highlight because as Toby said, we didn't want to replace the existing system. We wanted to smarten it up a little bit and add some new technology to the existing system without disturbing the workflow of the revenue managers because they had their established workflow and we didn't want to change that because it's already working for them. So why should we intrude there? So one of the goals was to create the application in a way where it's easy for them to use Infinity and use the predictions that we produce and the optimizations that we produce without having to interact too much with the system and without having to leave their workflows for a long period of time or changing how they have to work. And I think that was also very important. We had a workshop on user-centered design to really identify, okay, what do they need from our application and what do they not need from our application, so that in the end we had a very lean user interface for them to interact with.
Yeah, that human-machine interaction obviously is extremely important. You can build the best model, you can build the best UI, but if it's not intuitive and if it doesn't make sense to the workflow for users, then it will not be accepted and not used. Obviously, it has to have the right impact, but it needs to be easy to use and have user buy-in as well to actually make a business impact. So Toby, we've wrapped up that project. So we've iteratively worked together on it for I think a surprisingly short amount of time, if I think about it. I mean, we've worked on it consecutively for 2 years, last few times, but the overall production and development time was relatively short, each time in between. So how is currently the Infinity platform used at Eurowings? What can users do or what can your team do when they use the Infinity platform, and what kind of business impact did it have for Eurowings?
Yeah. So key was, as Christian already said, to include this Infinity tool in the process flow of revenue management. That was very important. We sharpened this during the project several times. What is the real task of Infinity? And this is that Infinity is a second algorithm the analyst can use to optimize flights. And this has had to be embedded as good as possible in the current workflow of the revenue management analyst. And that's what we did. That's why acceptance rate is good. People see in their current revenue management tool KPIs from Infinity. There is an easy graphical user interface. So they make the decision there. They see KPIs, they can compare KPIs, they benchmark what Infinity does, and they don't need to leave their system for that. If they decide, yes, Infinity is delivering good results on that route, they can go to a graphical user interface and just, we call it auto accept rules, accept Infinity on specific routes. This can be done on different aggregations levels. And this is exactly what Infinity is for. We don't want to create a new reporting, a new GUI for completely new end-to-end processes. We wanted to create an engine, a second engine for revenue management analysts they can use if it makes sense from their perspective to make more money on their flights. In the end, the decision, the driver's seat, is on the analyst side. They decide when to turn it on and when to turn it off. And yeah, we see good acceptance rates. We see transparency in numbers. And what's the benefit? Certainly, forecasted currency comes always along with positive revenue impact. We see 2-digit improvements of forecasting a currency. Wow. So impressive results. Certainly with our heterogeneous network, on some routes it works a little bit better, on some routes it works a little bit worse. But overall, we see a lot of acceptance of the application and using the Infinity forecast.
Excellent. So how much percentage is currently being used Infinity for the total inventory?
It's about 25% of entire network. So we're talking about 150,000 flights per year. We have predictions 365 days out. And around one quarter is optimized already.
Wow. Excellent. Thank you very much for your time. It was really a pleasure. The project itself was a lot of fun for us. So Tobias, also thanks for your trust throughout that project and for talking and sharing a little bit with our online audience about the work that we've been doing together with Eurowings. And hopefully we'll continue delivering impressive results, and the acceptance rate will go increasingly higher and the model will perform better each and every time we work with it. So thank you very much for being here and for sharing your expertise in building machine learning applications for revenue managers. And thank you, Christian, as well, to share a little bit more of the project insights. Thanks.
Thanks a lot. Thank you.
Thanks.
Dear passengers, thanks for choosing zeroG. We hope you had a great and informative flight. See you next time.